Because if you've got the product of two quantities equal to 0, one of the two quantities has to equal 0, right? If I tell you A times B equals 0, either A has to be 0 or B has to be 0, right? So what we're going to do is the whole reason you factor is so that you can set your factors equal to 0 to solve a problem. Right now, x squared minus 9x plus 18, I'd have to guess and check a long time for what x is to make it equal to 0. Am I going to plug in 1 and see what happens? Plug in 2. You don't want to guess and check. So we're going to learn how to go from the trinomial to the binomials. You don't know how to do that yet. But if it's in this factored form, what would make this first factor equal 0? So what would I have to plug in for x so that x minus 3 will equal 0? 3. So my solution to this problem, x either has to be 3 or what? 6. So from factored form, it's really easy to tell the two solutions. If I plug 3 in up here in this top equation, just to check that it works, right? I would do 3 squared minus 9 times 3 plus 18. Voila, comes out to 0. And if I plug in 6, 6 squared minus 9 times 6 plus 18 comes out to 0. So I was able to get the two solutions very quickly in factored form. I would have had to guess and check a long time in standard form. So number 2 is already in factored form for you. This 2 out here is just a factor of 2. That can never be 0. What would x have to be in this first parenthesis? Yep, so x is negative 2 or what? Negative 1. So if I plug in negative 2, I get 0. If I plug in negative 1, I get 0. Number 3, what would you say would be your solutions for number 3? What would you have to plug in here to get 0? Oh, yep, here you'd have to plug in 5. And out front, x itself could just be 0. Because 0, right? If this is 0, then this parenthesis would be negative 5. 0 times negative 5 is 0. If I plug in 5, I would have 5 times 0, right? So you're just trying to make one of your two factors equal 0. On number 4, x minus 10 squared, what's the only solution? 10. Remember last class we talked about some parabolas have one x-intercept, some of them might have no x-intercepts, some of them have two x-intercepts. Sometimes you might only have one solution to a quadratic. This graph, right, isn't it shifted right 10 and it goes concave up? So it only has one x-intercept at 10. So you can think of graphing as well. What about number 5? What would x have to be? Yep, negative 4 or positive 3, because if you plug in negative 4 plus 4 would give you 0 right there. All right, what about number 6? What would x have to be in number 6? Negative 4 or 0. Right. When there's an x by itself out front, or even if this was 2x or 3x, x times anything is 0, x would have to be 0. All right, 7 and 8 are a little bit harder. Maybe you can't do these in your head because they're no longer just plugging in like negative 2 right here. You've got 3x plus 2. So what I would do is algebraically, I would write out two equations for yourself. All right, 3x plus 2 has to be 0, and 4x minus 1 has to be 0. Solve the two equations for x algebraically. And they might come out as fractions or decimals. That's okay. So on the first example, you would subtract 2 to the other side. So 3x equals negative 2. And then you'd have to divide by 3 on both sides, right? So your first answer would be negative 2/3. It's okay to have an x-intercept that's not an integer. Most of you, when you did your projectile, you got like, place it, 221 point something centimeters away. All right, and then on the next one, you would add 1 to the other side. So you'd have 4x equals 1, and then you'd divide by 4 on both sides. So x would be 1/4. And if you plug in 1/4, 4 times 1/4 is 1. 1 minus 1 is 0. It should work when you check your answers. Could you try number 8 on your own? All right, don't say the answers out loud. Try to get... So there's no harm in writing out the equation, doing every step, writing it all out. But I think in time, you're going to realize that all you really have to do is take this number, the -2 in this case, add it to the other side and divide by 4. So I can see that my answer is 2/4 just by looking at it. Up here, you'd subtract 4 to the other side and divide by 2, so -2. So, you know, you're getting more sophisticated in your math operations in your head. So if you still need to write out all these steps, that's fine. But you can make the problem a little bit shorter by starting to do some of it in your head if you can. Not that you have to. So the zero product property, when it's in factored form, it's easy to find the solutions. And I wanted to take a look at our very first method for factoring, and then we'll take a break and go outside for a walk. But this is the greatest common factor. You want to use this strategy first any time that you factor. You always want to look for a greatest common factor first. So here's some steps up here if you forget how to do it, but you find the greatest common factor of the coefficients, you find the greatest common factor of the variables, you write the greatest common factor outside parentheses, divide the original function by the greatest common factor, and write your quotient inside parentheses. It sounds more complicated than it is. So when I look at number 1, what could I divide every single term in number 1 by? 2. So 2 is the greatest common factor. Why is it not focusing here? Oh, because it's too dark in here, I think. Doesn't like me anymore. Shoot. Okay, so if I divide each of those terms by 2, I'm going to write 2 outside of a parenthesis. And then I'm actually going to divide each term in the original expression by 2. And I'm going to write inside the parentheses what I have left. So I would have x squared minus 2x plus 3. So this original function and this factored function, they have the same value. I could double check when I redistribute my 2. See how I have 2x squared minus 4x plus 6? So you should be able to get your original standard form back. Number 2, what is the greatest common factor in number 2? 9. So if you have 9 that you're going to factor out, what you're really doing is dividing the 2 terms by 9, and what would you have left? So inside my parentheses, what do I have left? X squared minus 9. So we're going to see on the next page how this could actually go a step further, but we're just practicing the greatest common factor step right now. Once you get to this step, there's usually another step that you'd have to take. All right, number 3, what would be the greatest common factor? What could I divide both terms by? No. 2, and in this case, there's actually a variable that I could also divide both terms by. So couldn't I divide by 2x this time? So you want to start looking at variables too. So most of you have never seen this from like Algebra 1. Okay, so that's good. You've seen it before maybe? Okay, so I think, yeah, we're on different playing fields, so that's why we're kind of going through each factoring like you've never seen it before. So you'd have left 3x plus 20, right? And 2x times 3x is 6x squared. 2x times 20 is 40x. And you should be able to scan inside the parenthesis if there was another factor that you could pull out. You haven't pulled out the greatest common factor, right? So if this had said still like 6x plus 20, you could have still pulled out another factor of 2. So be on the lookout that you factored it completely. So let's just keep doing them together so we kind of get through it. What would you pull out for number 4? 3. Only 3. So why don't you try 4, 5, and 6? And then when we get to 7, 8, and 9, we can do them together. So try 4, 5, and 6. All right, so this first one you took out a 3, right? So you'd have 3 times x squared plus 2x plus 3. Good on that one? Number 5, you took out 5. So 5 times 2x squared plus 4x plus 1. Can everyone make sure that they put a 1 there? Because it's not just that it's gone away. When you actually divide 5 by 5, you have to have that 1 there as a placeholder. See how when I distribute it back out, I get 10x squared plus 20x. I have to have the 1 there to get my 5 back. So it's not just that it's gone. You have to represent it with a 1. And then the last one, you took out what? 9x? 9x times x minus 2. So if you didn't take out an x, make sure you write that in there because that's important. Right. And you want to make sure that you're good at this step because if this step's wrong, you're not going to get the right solutions. So what's the difference between like number 4 and number 7? 7 now has an equal sign. So now they actually want you to solve and find a solution. In number 4 and 5, all they want you to do is practice your factoring strategy. Factoring's great, but by itself, it doesn't do you anything, right? So you need to be able to use factoring to actually solve for a solution. So number 7, still kind of blurry here, but let's factor it first. Oh, man. Okay, it's the best I can get. So what are you going to factor the left-hand side using greatest common factor? What would you factor out? X, right? You'd have x times, and then you're dividing each term by x. So x plus 5 equals 0. So now I'm back to where I started with the 0 product property. I don't understand why. It's 5, right? Those are my 2 x-intercepts on the graph. And then why don't you try 8 and 9? So you're going to factor it using greatest common factor, and then finally write your solution for what x would have to be.